Hi again, physics. We're back. This time we're doing from homework 4, problem 2. So Charlie, whose mass is 66 kilograms, is rolling to the right on a 2-kilogram skateboard at 1.50 meters per second. Alice tosses him a 10-kilogram medicine ball. If you're not familiar with a medicine ball, that's one of those big, heavy exercise balls. So it's basically just a big, heavy object she's going to throw to him. When he catches it, Charlie comes to a complete stop. So how fast did Alice toss the medicine ball? So just like usual, we start off with step What are we looking for, and what units do we expect it to have? What are we looking for? How fast did Alice toss the medicine ball? So what we want is velocity of the ball, and this is actually going to be the initial velocity of the ball. This is the velocity of the ball at the beginning of our situation here. So this is equal to question mark. What units does velocity have? Meters per second. So now we have to go on to step 1. Step 1 is the sketch. But this is a conservation of momentum problem. And anytime you're doing a conservation problem, you actually want 2 sketches. You want a sketch for your initial situation that shows you what's going on at the beginning of the problem. And then you want another sketch for the final situation. So what have we got in the initial sketch? We've got a skateboard, Charlie. Charlie's moving to the right on the skateboard. The skateboard's going too. And we have Alice. And she has tossed a medicine ball towards Charlie. So there's the medicine ball going that way. And we need to figure out what's going on here. So mass of Charlie, m sub c. Well, it says right here the mass of Charlie is 66 kilograms. But notice Charlie is stuck to the skateboard. Charlie and the skateboard are always moving together. So I'm going to say the mass of Charlie is actually 68 kilograms. So it's the mass of those 2 things together. And they have some initial velocity. V Charlie initial, that's that number. 1.50 meters per second. Now the other thing that's going on here is we have the medicine ball. So mass of ball is equal to 10.0 kilograms. That's that number. The velocity of the ball initial is equal to question mark. This is actually what we're looking for. So Alice presumably has some kind of mass herself, but we don't actually know what that is. We don't really care what that is. We don't care if she's moving or not. She's not really in our system. We just care about what Charlie and his mass are and their velocity, and the ball and its mass and its initial velocity. So on to our final sketch. So what is happening at the end of this situation? We have a skateboard. Charlie is on the skateboard. He's now holding the medicine ball. And Alice is probably still there. She's very happy about everything that's happened so far. So the mass. Notice that Charlie and the ball are now stuck together. Problems like this, we call them perfectly inelastic collisions. So mathematically, if things are stuck together, we do that with parentheses. So mass of Charlie plus mass of ball is equal to 68 plus 10 kilograms, 78 kilograms. And at the end, again, velocity of, okay, well really they're stuck together. Velocity of Charlie plus the ball, final, but that's a lot to write. And turns out there's only one final velocity in this problem, so I don't need all of those subscripts. I can just call this VF, velocity final. And notice, they came to a complete stop. Notice there are no speed lines, so neither Charlie nor the medicine ball is moving. So the final velocity is just going to be 0 meters per second. On to step 2. So step 2 is write the law of conservation of momentum. So sigma p initial with a hat plus j external, so any external impulse we have with a hat, is going to equal sigma p final, also with a hat. So in step 2, everything is a vector, everything is plus together. Now we have to look at these terms and start to deal with them. Well, one thing is j external. We don't have any external impulse in this problem. That's just going to be 0. That's going to go away. That's very common in these problems. So sigma p initial, sum of the initial momentums. Look back at your initial sketch and just make a list of everything that might have momentum, put a hat on it, and plus it all together. So it seems like Charlie might have initial momentum. So sigma p sub ci, I'm sorry, not sigma, just p sub ci with a hat. And again, step 2, so everything is plus, everything wears a hat, plus the initial momentum of the ball. So p sub bi. Plus j external, well that's 0, I'm not even going to write that. Plus sigma p final. So that's going to be momentum of Charlie and the ball final with a hat. But again, notice they're not moving. Their velocity is 0, so I know already that their final momentum is going to be 0. So I'll just rewrite this. P sub ci with a hat plus P sub bi with a hat, all of this equals 0. So I have something plus something equals 0. But I know that these things are vectors, so that's going to work out okay. So on to step 3. Step 3 is math. The first part of math in a problem like this is to take off the hats and to put in the signs for the different things. So P sub ci, momentum of Charlie initial. Charlie's moving to the right, so I'm calling that positive momentum, so that gets a plus, P sub ci. Now for the initial momentum of the ball. That's going to the left, so I'm making that one negative. So P sub bi. A little bit of algebra. P sub ci is equal to P sub bi. I just added P sub bi to both sides. Now we get to that step where we have to sub in mv for all of our p's. And if we had any external impulse, if we had any j, we would sub in ft for that. But we don't in this problem. So I'm going to turn all of my p's into mv's, and I'm going to use all of the subscripts I need to make sure that this is clear what's going on. So P sub ci becomes m sub c vci, and P sub bi becomes m sub b vbi. So hopefully it's clear why we need all of these subscripts. I have 2 different masses, and I have 2 different velocities. So I need these little subscripts to help me keep clear what everything is. So the thing we're actually solving for is this, velocity of the ball initial. So I want to get that by itself on one side. So I'm going to divide everything by m sub b. That's going to give me m sub c v sub ci divided by m sub b, and this is equal to v sub bi. Now I'm going to take this over to the right so I have a little bit more room, and I'm going to switch left and right at the same time. So that's just going to give me v sub ball initial is equal to mass of Charlie, velocity of Charlie initial, all of this divided by mass of the ball. So now I've got to put in my numbers. So v sub bi is equal to mass of Charlie. Remember, Charlie and the skateboard are really one big mass. And we're saying that's 68 kilograms times the velocity of Charlie initial. That is at 1.50 meters per second. All of this divided by the mass of the ball, which is 10 kilograms. So if you do this in the calculator, you're going to end up with velocity of the ball initial 10.2 meters per second because it's velocity. Now let's be very careful how we state our final answer. So 10.2 meters per second looks like a velocity to the right. But if you look back at your sketch, you can see that the ball was going to the left. We dealt with that idea right here when we took the hat off of P sub bi, the momentum of the ball initial, and we gave it a negative sign. That's when we plugged in the idea that the ball is going to the left. So when I state my final answer, I need to be a little bit careful about that. So I can either write that implies that the ball is going to the left, but to be perfectly clear, I can also do it this way. V sub bi is equal to 10.2 meters per second to the left. I think that one's a little bit clearer, so I'm going with that one. So on to step, does this answer actually make sense? It's a velocity. We found the velocity of the ball initial. That's what we were looking for. It has units of meters per second. That's what we wanted to have. And the ball is going to the left, and 10.2 meters per second. Well, think of the bloody cheetah. 10 meters per second is about 20 miles an hour. That seems like a reasonable speed for Alice to throw a medicine ball with. So I'm going to say that that's okay. So that gets a check. So hopefully this makes sense.